potential energy and kinetic energy. I can see Angelina, I can see JC, Mulehi, Fiso. All right, you are all welcome. I hope you are ready for the lesson. Okay, so without wasting much time, let's go straight. All right. So we're going to look at what potential energy and kinetic energy. Okay. And then our lesson objectives are by the end of the lesson, you should be able to define the term energy as what the ability to work. Explain the potential energy as the energy in a stored system. Okay, describe the different forms of potential energy and read energy content that are in different foods from the food packaging. All right. Now, but before we go on, we need to look at an energy system. So, what is an energy system? Energy system is any object that has got energy in it and is able to use that energy to do work. In other way, we can say any object that has energy will have the ability to do work. So it's just like sometimes when you are very hungry, you see that you are, when they give you any assignment, you cannot do it. More especially physical activity, you cannot do it because the energy that is stored in you is depleted or is finished. So you can consider yourself as a system. And then when you have the energy in you, you can play soccer, you can listen to your teachers, you can do your homework or what have you. All right. Now we should know that energy can neither be created or destroyed, but it can be transferred from one energy system to another. And then this is according to what the law of conservation of energy. All right. An energy system is a group of parts that work together to change what energy from one form to another. For example, a wind turbine is an energy system. All right. So having said with this introduction, we will go on to what potential energy. So what is potential energy? Potential energy is energy that is stored in an object or system. So we are going to look at the three types of potential energy. One, we have got what is called elastic potential energy. And what is this elastic potential energy? A stretched elastic band has elastic potential energy because it moves. That is, it does work when it is released. So elastic potential energy is the energy that is stored in what? Rubber bands, if I can say so, or anything that is elastic, we can say that is what? Potential energy. All right. Then we have another one that is called gravitational potential energy. A gravitational potential energy is a weight balance on the edge of a table. So if I have a table, then I have something close to the end. If I look at it, then the table, from the ground up until to the top of the table where the book is, because of the height, the book is having a what? A gravitational potential energy. So an object is having a gravitational potential energy if it is above the earth surface. So for example, I have a table, let me repeat this again. I have a table and then there is a book just by the edge. If I leave the book, it will fall down because of the height. So that is an example of what? Gravitational potential energy. Okay, we have another one also called what? Chemical potential energy. This is energy that we all have in our system because of the food that we eat. Okay, the food we eat has chemical potential energy. We obtain energy to live from the food we eat. Cells, or into bracket battery or fuel, also have what? Chemical potential energy. So what it means is that chemical potential energy can be found from food. It can be found from what? Cells or battery. It can also be found from what? Fuel. Fuel like the petrol, the paraffin, the diesel, and the rest. Okay. Any object that has energy has what? Potential energy to do work. And remember, the unit for measuring energy is the what? Joule. Okay. And it can be transformed from one form to another. I can have an object having potential energy. The next moment it is having what? Kinetic energy. Or an object can have what? Kinetic energy. The next moment it is having what? Potential energy. So let me just explain this thing. Okay, I have a football or a soccer ball on the table and it is at rest. It is not moving. It is just at rest. Then it is having one potential energy. Now what happens is if I disturb the ball, if I flick it, it will roll down or it will roll and fall down. So it has changed from its initial position, that is when it was having what potential energy, and then it falls down. Then the potential energy is changed to what kinetic energy. All right. Potential energy is energy that is stored in an object or system. So I've just said that. Now let's look at illustration. The first one, we said that we have got three types of what potential energy, and the first one that was mentioned was what elastic potential energy. So you can see a straight elastic band has potential energy. So when you stretch it, okay, then immediately you leave it, it can fly. So it can change from potential energy to kinetic energy. Okay, so let's go to the next one. All right, let's see more explanation. So this explanation is for the stretch band. If we release a stretch elastic band, it will fly across the room because it has got what elastic potential energy when it is stretched. So I've just explained that some minutes ago. Now let's go on to another illustration here. So when I place, as you can see, when I place a weight or a book or any object on the edge of a table or even a cliff, as we can see, the weight of the book balancing on the edge of the table will fall to the ground if it falls off the table. The weight has got what? Gravitational potential energy before it falls because of its what position above the ground. If that object is lying on the ground, it will not fall, meaning it is having what potential energy. So even where you are seated, if you are sitting on a chair or a sofa and you are listening to this, you are having what potential energy. But immediately you get up from wherever you are to pick something, you are now transforming your initial energy, which was potential energy, to kinetic energy. That is to wherever you are going. All right. Then more illustrations for potential energy. So look at the brick. The brick does not have potential energy. Why? Because it is lying down. Now look at the guy there. He has picked the brick. This brick has got what potential energy because it is having it is at a certain height above the what the ground. Okay. So if you are asked to explain why the one that is lying on the ground does not have potential energy, but the one that is lifted a bit above the ground or the mat is having potential energy, is that this one lying on the ground has got no potential energy because there is no height between the brick and then the surface of the earth or the floor. But meanwhile, this one that is raised up has got what? Potential energy because it has got, there is a distance between the surface of the earth and that of the brick. All right. Now let's look at potential energy in a cell or a battery. You remember we said we can get energy from the food we eat, from the what? The cell or battery, and from and then from other sources like what fuel. Now, a typical example of potential energy in a cell is this one. So batteries are a source of what potential energy for electric circuits. All right. Now the cell will light. So supposing I place this one in a torchlight or connect it so that there is a complete circuit, whatever will be connected to them, for instance, a light bulb, the light, the cell will light up the light bulb if it is connected to an electric circuit. Why? Because the cell has got what? Energy stored in it. This energy is called what? The chemical potential energy. All right. I hope I'm not moving fast. You guys, you can send me a message if I am moving fast to your liking so that I can move slowly. Okay. All right. So if you are listening to me and then you are hearing me well, that's good. I was just wondering whether I'm too fast or too slow for you. Okay. So let's continue with our discussion here. All right. Now I'm going to the next slide. Okay, the next slide, you remember in one of our objectives, we say we should be able to interpret what we have on food packaging. Right now, I have a word. I go to buy a certain food item from the shops, and then I have the specifications there. So now I have the food in food type and then the energy per gram. So I have chips that is about 1995, which is simply 1995. I have wheat flour, which is 1467. I have chocolate, which is 1737. I have chicken, which is 8800. And I have potato, which is what? 1440. Now the following question says, which food type has the most energy? So is there which food type has the most energy? So you can look at your food packaging box and then you can see this. So before I go on, I want everyone to post from your screen. The question is which food type has the most energy? Remember, the column on the right hand side represents the what? The energy, and that one on the left hand side is the food type, either chips, wheat, chocolate, chicken, and potato. So guys, can you, if you are hearing me, which food type has the what most energy? Can you post it just for 1 minute? Are you hearing me? Yes. Yeah, very good. Fiso, may you give me the reason? Yeah, that's good. Malaysia, that's good. All right. Okay, then let's continue. You have the idea there. Who is also sending in the answers? Okay, that's cool. Let's continue. And then the next one is saying arrange. So arrange the food types in order from the what? The food type with the highest energy to the lowest energy. So which one will be starting? Which one will be the first, second, and which one will be the last? Can you also do that? Okay, just brief. Just tell me which one is going to be the highest and which one is the lowest. Can you arrange that for me for question 2 also? Again, we are going to look at the package, the food package, and then arrange the food items in order from food types with the highest energy to the lowest energy. Yes, let me see you whether you are following here again. Yes, all right, let me see. Okay, yeah, somebody is saying that I should speak up. I think that maybe this person is not hearing me. Okay, I've heard you. All right. I was saying that the second question is talking about rearranging the food items that they have given us from what? From the highest energy to the lowest energy. So I was just saying whether you can do that before we continue. Okay. All right, chips. Okay. Uh, Somebody saying chips here, chocolate, followed by flour, followed by potato, and that is correct. That is correct. Okay, you're getting me. Now let's go. Let's look at task two within this packaging. So anytime you go and buy your chips or whatever, please look at the package and then you can see the different types of component or ingredients that is found in the food. Then you can then literally know that, okay, this one with the large amount of energy or percentage of energy is this one. So when I'm eating this, I'm gonna get this that much. Okay, now let's go to task two. What type of energy is found in food? Yes. What type of energy is found in food? Yes. What type of energy is found in food? May you please send your answer through before we move to the next? Before we move to the next? Yes. Remember, we just spoke about it. What type of energy is stored in food or is found in food? Guys, if you are listening, send in your answer so that we move forward. Okay, so you're quiet. Are you guys with me? Okay, and then the other question is, why do you think food packaging tells us how much energy is in each food type? Okay, very good. Mulei, yeah, you got it right. Chemical potential energy. And then arrange the food types in order of increasing energy in it. Or why do you think food packaging tells us how much energy is in each? Can somebody answer that? Why do you think food packaging tells us how much energy is in each food type? Okay, you have even done well. So let's leave this one and continue. We'll come back to it to see how much it contains according to Malehi. All right, that's a very good attempt. Okay, now let's go to the next slide. Okay, and the next slide tells you this thing. So those of you who did chips and then chocolate, wheat, flour, potatoes, chicken, you were very perfectly correct. And then the other one is what? Chemical potential energy. And then number two, it says it is important for us to know how much energy we are obtaining from the food we need. The more activity you do in the day, the more energy you need to keep doing those activities. Okay. Now, all the food, let's take note, all the food we eat has chemical potential energy. We can use the energy to breathe, walk, run, and do daily what activities. Every food packaging should have what information telling us how much energy is is how much I'm attending the library. How much energy in joules or kilojoules is in that food. Okay. The very question up, can I see someone who is, you cannot hear, but what is wrong with my system today? Okay, I will try to increase my voice. All right. Okay, can you guys hear me now? All right, so let's continue with the lesson. We are basically done with potential energy. So we're saying potential energy. Is it better? Can you hear me? Okay. All right. I think it's better now. Okay. Yeah. So let's look at kinetic energy. Kinetic energy is the energy that a body has when it is moving,
Let's
or we can
go.
simply say kinetic energy is the energy a body has when it is in motion.
Okay,
Or
those people.
kinetic energy is the energy that a body has by virtue of its motion. Okay, so let's look at some examples of objects that have kinetic energy. Okay, now number one or A, when a stretched elastic band is released, it shoots across the room, meaning it has got what? Kinetic energy. When a weight falls off the table, it has got what? Kinetic energy because it is falling. When cells, for example, in a battery are connected to a closed circuit and current flows through the circuit, then it has got what? Kinetic energy. When cars drive around, they have kinetic energy because they are moving. When water is falling over a waterfall, it has got what? Kinetic energy. So you see that all these things are in motion. So note any object that is moving has kinetic energy. So when you go to school and after your lessons and you are moving from one place to another, you are having kinetic energy. And remember, the unit of measurement is what? The joule, just like that of what? Potential energy. I'm the only one talking here, but I'm also hearing noise from that background. Molehi, I'm also hearing some talking from that background. I'm just the only one here. Okay, let's go to the next. All right. Now let's look at some illustrations of what? Kinetic energy. So the first one, you can see this guy who is sliding uh, down the inclined plane. It's having what? Kinetic energy. This person or this lady is having what? A ball. She's holding the ball above a certain height. So at the point of no motion, it is having what? Potential energy. So you can see that look at the moment she's holding it, it's having potential energy. But immediately she releases it, then what? It changes from potential energy into what? Kinetic energy. We can also see this lady who is running is also having what? Kinetic energy. So these are just illustrations to show that when an object is in motion, the object is well having what? Potential energy, kinetic energy, or possesses what? Kinetic energy. And we must also remember that an object or a body can transform or move from potential energy to what? Kinetic energy, and then vice versa. Okay. Now let's look at more illustrations. You remember I just showed you a slide whereby somebody was pulling a what? A band. Now, if this band is released so that the band flies across the room away from the learner, what it means is that that one has what kinetic energy because it is moving. It's moving from your arms that was stretching the what? The tabard or the rubber band. Okay, so equally, if you place a table, an object on the surface of a table just by its edge and you leave it, it falls. It's having what? Kinetic energy. When you switch the light in the room, for example, wherever you are seated in the classroom or in your bedroom, then you switch the light what? On or off. If you switch the light off, what is going to happen? Then the switch and switch them back. What is going to happen is that the lights are going to be switched on or off. When the lights are switched off, it means there is no current that is moving. But immediately they are on, current flows. Then we are able to see the light in the room or in the classroom. Here, the electrical current has got what? Kinetic energy when it flows from one point to another to lit the what? The bulb. Now, equal another illustration is when you have got what? A cup of water and then you are pouring it into another. That is kinetic energy because the water is moving from one end, in this case, the cup that you are pouring from, to the other one that is collecting the water. So the water is having what? Kinetic energy as it falls. Okay. All right. Now, more illustrations. So let's see, look at the stop sign. Does it have kinetic energy? Yes or no? It's stationary. So because it's not moving, it's no. The reason the sign does not move and so does not have what? Kinetic energy. That's perfect. Okay. Uh, yes, I'm currently seeing you. I'm currently showing you examples, so you can check there. You can just check on your slide. So let's look at this roller coaster. The roller coaster there is motion. So it says, does it have a kinetic energy? Yes or no? Yes. The reason the roller coaster is moving and so has what? Kinetic energy. Okay. Now let's just look at the garden chairs. Does it have kinetic energy? No. Give a reason. The reason the chairs are stationary and so do not have what? Kinetic energy. Let's look at the other one also. We have got what? An apple. That is, does it have kinetic energy? Yes or no? No. From the illustration I'm giving you, the apple is still on the surface. It is not moving, so it does not have what? Kinetic energy. If we look at the helicopter, it doesn't have kinetic energy. Yes, because it's in what? Motion. Okay. All right. Let's go to the next slide. The next slide, I was just trying to explain them to you. So yeah, I can see you are saying no, yes, yes. Yeah, it means you are following the lesson. Okay, let's go to the next. Okay. Um, then what I have here is there are questions for you. But before we continue, I want to, it's like the system is bad from, I don't know from where, but just let me know if there was any slide that you are not clear, or you, as those of you who said you were not seeing, I can go back to the slide before we can go to the questions that we're supposed to do. So guys, send in your questions, more especially who Pele, who said she couldn't, or he or she couldn't hear me. So please just ask your question, then I will try to explain before we go to the questions. If there was a slide that you were not clear about or clear with, okay. All right. Now I have something on the screen for you, and it's assessment. So today is like we are doing more of the activities so that you will go through we will go through with this topic very clearly. All right, now let's look at the assessment on board or on your screen. So the first question, this one, it just needs one word answer. It says, what type of potential energy does food contain? So you just give your answer. All right. And then uh, this one is saying, okay, what type of potential energy does a man standing on a chair have? So let's just look at question one first. Keep your answers coming through. Okay, number one is chemical potential energy. Okay, let's proceed. You can proceed to question two. So when you get to question two, we will make sure that all of us are in line so that we can move together. Guys, I'm only seeing Mulehi answer for question one. So send yours through. Are you guys there? Oh, Junior, you are with Mole. So apparently it means so Junior's answer is also your answer. Okay, I understand. All right. Okay, I understand. So the three of you have got the same answer. Then you must get total because you are doing together. Okay. Number two, it says what type of potential energy? Listen to the question. What type of potential energy does a man standing on a chair have? The man is standing on the chair. So what type of potential energy will that man possess or have? Hmm. You say agree kinetic energy. Oh, okay. Yes, guys, look at the question. It's potential energy, but what type of potential energy? Very good. Yes, I can see Junior. Yes, Junior with your group. That's correct. So the man is standing on a chair. So it means that the chair is at a height above the ground. Hence, it's going to be what? Gravitational potential energy. Okay, let's get going. I can see the answers for the rest of you guys. Okay, see, so you are too quiet. Okay, so let's go to what? Number three or question three. Let's go to question three. Let's go to question three. It says, what is the difference between what gravitational potential energy and chemical potential energy? Gravitational potential energy and chemical potential energy. So remember, it means you are supposed to what? Give some differences. You can use their definitions to get your answer, or you can even use whether you can use the reference in terms of the ground, whether this one is on the ground or above the ground or wherever, just to assist you to get the answer. So here, try to explain it. Okay, I'm waiting for your answers, guys. Send them through. Okay. Yeah, Hopelin, may you please check your answer? Double check it again. Okay, someone is saying chemical potential energy is in the food we eat. Okay, yeah, that's a nice way of differentiating. Then you can say, and then gravitational potential energy. Then you add it, and then you will. That is the good or nice way of differentiating. So Mulehi, you have done the first part of the difference or differentiating. Is left with what gravitational potential energy. So try to do that. Okay. Yeah, send your answers through. FISO, also check your answers. FISO, if you check your answer, you saying potential energy is when someone or something move, and gravitational energy is when you don't move. So remember, you are differentiating between kinetic energy and potential energy. But remember, this question is saying, what is the difference between gravitational potential energy and chemical potential energy? So take note. Even though you have, that's a good effort for trying, but try to get the, yeah, yeah, you are wrong if you said that potential energy is when something or someone is not moving. Oh no, that is for speed. So okay, chemical potential energy. No, hopefully you are correct because you are saying chemical potential energy is stored in what? The particles of substances. Yeah, you can also say that because they are at rest. So in the object, the particles are at rest. So hence, when there is no motion, then we can say there is potential energy. But immediately there is motion, then it's no longer potential energy, but what? Kinetic energy. Yeah, so hopefully you are correct. I was referring your answer to sphere, so that's fine. Okay, so you are right. Okay, all right. Guys, let's move to question 4. Let's move to question 4. Question 4 is saying, which of the following is an example of elastic potential energy? A banana, a compressed spring, and a bag on a chair. And a bag on a chair. Yes. What's the answer? This one you just need to pick up. You just need to pick. Yes. What are your answers? I know you are typing, but okay. Let's see. Yes, somebody saying compress. Yeah, that's correct. Perfectly correct. Okay, let's go to the next. Next. Now, so you have two. Yeah, Junior, you are correct. Molehi, Angelina, Mien, and Speed. So you are correct. All right. So it's like this one, you are getting it 100%. Question 4, and even the previous ones. All right, now let's go to question 5. Question 5 is saying, which type of energy do each of the following statements contain? Kinetic or potential or both types? So you are going to check a body biker at the top of the what mountain. Is it potential energy or kinetic energy or the two of them? Okay. So you are just going to say 5. A, if it is potential energy, you write. If it is kinetic energy, you write. If it is both, you write. Okay, so you go to B, petrol in a storage tank. Petrol in a storage tank, what is it? A race car traveling at its maximum speed. Is it a race? Is this race car having a potential energy or kinetic energy? Then we're looking at what? D, which is talking about what? Waterfall. Water flowing down a waterfall before it hits the ground. Okay, let's move on. A spring in a pinball machine before it is released. That's great. Then last but not the least, a running refrigerator motor. Okay, so let's check your answers through. Okay, so a mountain biker at the top of the mountain, at the top of the mountain. So here again, check. I want you to double check your answers. I want to see the one who will get number 5 all total. If you got the illustrations I gave you regarding the examples, or all of them are there. So you just need to remember or apply them to this, and then you're gonna get it. Okay. All right, let's get going. It's getting to time. All right. So what about a running refrigerator motor? I've not seen someone doing that. What is it? That's F. A spring in a pinball machine before it is released. What is that? Water flowing down a waterfall before it hits the pond below. What is that? Okay. Let's keep the ball moving. All right. In the next few minutes, we are going to do the corrections so that I will see those of us who got total. So somebody is saying a spring in a pinball machine before it is released. Okay, Junior, you're saying, all right. Me and I like the way you have answered. Yeah, A is this, B is that, C is that, D is that, and what? D is that. Yes, A, B, C, D, F. Okay, all right. So yeah, you think, don't worry, we will mark now. Don't worry, we are learning. So at the end of the day, you will know. Yeah. So if you are still thinking, at the end of the day, when you think you will get what we are doing here. All right. Now I'm going to I'm going to the what? The corrections now. Are we ready? And I want to see you guys getting total, more especially number 5. Okay. Can I go to the next? I need your response, yes or no. Can I go to the corrections? All right. Cool. That's nice. All right, let's go. All right, there you go. First one, potential energy, gravitational potential energy. Gravitational potential energy is the energy an object has due to its position above the Earth. Take note of that. And chemical potential energy is the energy that is stored inside the what? machine. Okay. So chemical energy is the energy that is stored inside the substance, like food. So if we're talking of fuel, this fuel is inside the machine and it can be able to power the machine to move. Just like we human beings, when we eat, we are able to run, to study, to jump, or whatever. Okay. And then number four is compressed spring. Most of you got that right. Number five, as we can see, is potential energy, kinetic energy. D is talking about the two energies, that is potential and kinetic. D9 is talking about potential energy and kinetic energy. All right. Guys, was the lesson enjoyable? All right. If let's go to the okay, we still here. I can see most of you have got some questions. All right. You got all of them, seriously. All right. Well done, well done. Oh, cool. Eh? So, time. I must go to the next class. Okay. Yes, it's time. Okay. It was nice having you around. Uh, See you next week and then enjoy the rest of your lesson. And take care because the virus is real. Social distance, wash, and then what? Face mask. All right. Bye.